Hello everybody, today we're going to talk about best practices on cooling systems. Today we're going to show you the proper way to drain and fill on this particular model. On this particular model, this radiator has a petcock that the technician is undoing so that they can drain the coolant out of the cooling system. Not all models will have a petcock. Sometimes you need to take off the lower rad hose in order to get the coolant out of the cooling system. So this technician here has a catch bucket, catch basin, doing their best not to get it all over the floor because it can be hazardous. On this particular lower rad hose, there's a sprung steel clip that this technician has a special tool to get in there and open that up. Once that clamp is opened up, they can slide that down the lower rad hose and get the lower rad hose off the bottom of the rad.
After the technician has completed the repair and replaced any components, it's time to fill. Here we have OEM coolant and we have distilled water, which is what's recommended to fill the vehicle with, and they are placed in this bucket. We are seeing all the components here of this vacuum cooling system filler, sometimes referred to as a coolant lift. The technician is assembling the tool as per the directions that came with the tool and installing an air hose to the end of this tool. This tool uses the Venturi effect to put a vacuum on the vehicle. Here you can see that valve is in the closed position, and this is the vent hose, and we have a piece of rag there to make sure that any moisture that comes out is caught. So I'm pushing down on the tool at the moment to make sure that I have a tight seal. Here we can see that a little bit of vacuum is starting, but it is struggling. So sometimes you have to double check that seal and push really hard. If no vacuum is obtained, there's probably a leak in the system. Here we are continuing with the process, and we can see the vacuum gaining substantially. We want to get to about that 20 to 25 inches of mercury range as seen on this dial. And as we look down here at the rad hose, we'll see that the rad hose is actually collapsing on itself under that vacuum, and that is normal, and that's a good thing. So this vacuum in the system is going to remove any air from the system, and the vacuum will suck in the coolant once it's ready to go again with that Venturi effect. So what we have over here is our bucket of coolant, and we are lowering the end of the tool into it, making sure it stays in the bottom. And then if we go up to the other end of the tool, what you can't see very well in the diagram here, the video rather, is there is a button on the bottom where the technician's left hand is. So opening the valve and pushing the button will bleed any air out of the system before it enters. And then by opening that valve and not pushing on the button, the coolant then enters into the vehicle's cooling system. We will slowly see the vacuum come down as the coolant fills the cooling system. We'll continue on with this in a moment, but while we're doing this, make sure that we keep checking the bucket to make sure the bucket of coolant remains filled and the end of the hose remains in the bottom of the bucket. It's important to make sure that we're not sucking air up. If you do need to stop, close the valve so we do not suck any air into the system, as that would be counterproductive to this process.
Now we're checking the system with a pressure tester. We're going to make sure that everything that we've put back together doesn't have any leaks in it. Another way of checking this would have been with the coolant lift is to check while it's under vacuum. Making sure that that needle doesn't move would be a really good indication that the system is probably airtight. Now we can see that with the system under pressure, with coolant in the system, we can see that it's taking the pressure and it's holding the pressure, an important step before our next step, which will be going for a test drive to make sure that the cooling system is functioning properly. So we can look down while it's under pressure and make sure that we don't see any obvious leaks coming from anything that we have repaired. The gauge appears to be holding good pressure, so I can take the tool off of the system and put the cap back on, and maybe one more check underneath before we go for a test drive. While we're on our test drive, we're going to check things to make sure that it is giving out the proper heat that it was designed to do. And after our test drive, we're also going to make sure that we don't see any leaks underneath. So what's happening here, these are coolant test strips. These not only test for the strength of the coolant, they are also going to test the alkalinity and the pH, which in today's vehicles is a very important step. So comparing it to the container, we can see that the colors are in the parameters that is recommended by the OEM manufacturer.
If you have a look at this Mazda, we can see that there's a radiator cap attached directly to the radiator, and then on the right side there's a coolant overflow. When you get a vehicle like this, it's important to fill the radiator, whether filling with the bottle or filling with the vacuum system, to fill directly into the radiator via the radiator cap and not the overflow.
If you don't have access to a coolant lift, several vehicles are equipped with a bleeder screw that you will be able to find through OEM information. While filling the coolant, the idea here is to take the plug out, fill the coolant, and the air that is going to be in the system will be pushed up through the vent as the coolant enters the system.